Okay, this is the 2-4 complex numbers in class notes for page 150. In class, you're going to be doing these when you're at home. You got another video to watch for the problems at home. So we're going to do just a few of these. So definition of a complex number, which if you already saw the other video, is a plus bi. This part is called the real part, and this part is called the imaginary part because of the I with it. Mr. Downing's friends doesn't, that's supposed to be a Y. And doesn't exist like Mr. Downing's friends. So over here it says multiplying complex numbers. So you're going to do these just like you did in the old days. So you're going to do FOIL. So you're going to take 7 times 3, and that's going to equal 21. And then you're going to take 7 times negative 5i, and that's going to be negative 35i. And then you're going to take negative 2i times 3, that is negative 6i. And then you're going to take negative 2i times negative 5i, that's positive 10i squared. Now, if you did not watch the last video, or if you have not seen the at-home video, I equals I squared is negative 1, I cubed is negative I, because it's I squared times I, negative 1 times I is negative I, and then I to the 4th is I squared squared, so negative 1 times negative 1 is 1. And then when you get to I to the 5th, that goes back to the first one. I to the 6th is the second one, and so forth. It just repeats every 4. So why I'm telling you that is because we need to take this I squared, because you're not allowed to use I squared. Your answers can only be in this form right here when you're dealing with I. It's got to be one of these 4 numbers. So the first thing you want to do here is you want to take this I squared, and you're going to take and you're going to plug negative 1 in for that. So you can get 21, and these two are like terms because they both have an I. So that'd be minus 41i. And then this would be plus 10, and you plug in negative 1 for the I squared. So negative 1 times 10 would be 21 minus 10 minus 41i. And then 21 minus 10 is 11 minus 41i. You notice I'm putting a little tail on my eyes. You need to do that because if you don't, if you do something like that, it might look like a 1. So put a little tail on your eye. So this is the answer to number 32. I'm going to do one more. I'm going to do 38. So this is 5 minus 4i. So squared means you got it again. You got 5 minus 4i again. So you take 5 times 5 is 25. 5 times negative 4i is negative 20i. Negative 4i times 5 is also negative 20i. And then negative 4i times negative 4i is positive 16i squared. And again, instead of this, we want to think of this as being negative 1. So you're going to have 25 minus 16. 25 minus 16 is going to be 9. And negative 20 and negative 20 is negative 40i, and that's your answer. Then we get down here to this next part, multiplying conjugates. So a conjugate, if you have a plus b, the conjugate is a minus b. It's the exact same it's the exact same. This is a binomial, and this is its conjugate. A conjugate's the exact same 2 numbers with a different sign between them. So when you start doing these problems with conjugates, you're supposed to write the complex conjugate, and then you're supposed to multiply them. Well, I'm going to show you a shortcut on multiplying conjugates. So if you remember, when you have a squared minus b squared, a difference of squares, when you factor it, you get a plus b and a minus b. I don't know if you ever noticed this, but these 2 numbers are conjugates. So whenever you FOIL conjugates, you get back the difference of squares. So the shortcut is square the first term, put a minus sign, square the second term, and that's the answer. So when I do number 40, the conjugate is going to be 8 plus 10i because that's a minus. So when I FOIL 8 minus 10i times 8 plus 10i, I'm supposed to tell what you get when you multiply the conjugates. The shortcut is you're going to take 8 and square it and get 64. You put a minus sign and you square the 10i, and that's going to be minus 100i squared. And then again, just like up here, I squared is negative 1. So in place of I squared, I want to think of this as being negative 1. which gives me 64 plus 100, which ends up making this just the real number, 164. I'm going to do number 42. So the conjugate of 42 is going to be negative 3 minus radical 2i. Again, the real part stays the same. You change the sign of the imaginary part. And then I'm going to FOIL this. So I'm going to take negative 3 plus radical 2i times negative 3 minus radical 2i. And I'm going to use this same shortcut up there. I'm going to square negative 3. That's positive 9. I'm going to have a minus because it's a difference of squares. And then I'm going to square radical 2i. So when you square a square root, that brings the number out, and we get an I squared. So again, we want to think of this I squared as being negative 1. So this is going to end up being 9 plus 1. Or sorry, 9 plus 2, negative 2 times negative 1 is plus 2. This will be 11. So you can see the importance of multiplying by a conjugate. You get rid of the imaginary part. So that's what you're going to be doing on these. Now, the first thing you have to do here is you have to rewrite this as 15i. So you need to be thinking about this as being 0 plus radical 15i. And then you can do the conjugate. Okay? So the conjugate is going to be 0 minus radical 15i. Now, you don't even have to do the radical part on this one. You can just take radical 15i times negative radical 15i, because the zeros are gone. They give you nothing. So this is going to be a negative 15, because negative times a positive is a negative, and radical 15, that's radical 15 squared, brings that out, and then I got an I squared. And again, just like the rest of the I squared is negative 1. So negative 15 times negative 1 would make this positive 15. Okay, the next page. Now this says over here, write the quotient in standard form. Since I is the square root of negative 1, you're not allowed to have I in the denominator. And that's why we just did what we did a second ago. If I multiply this by a conjugate of this denominator, it will get rid of the i's in the bottom. So when you have a number like this, you're going to multiply the top and bottom by the conjugate of this denominator. So I put 1 plus I down here and 1 plus I up there. So now I distribute 13, and I get 13 plus 13i. And then when I FOIL the bottom, remember that's a difference of squares. So if I square 1, it's 1. It's a difference. And then I square I, that's I squared. And I hope we all remember again that I squared is negative 1. So I've got 1 minus negative 1, which gives you 13 plus 13i. And this would be 1 minus negative is plus positive. That's 2. Now, this is not standard form because you have to have two totally different parts. You have to split up the common denominator so that you have a real part and you have an imaginary part. So it'd be 13 halves plus 13 halves I. I don't like the way that 13 looks. Okay, I'm going to do another one. I'm going to do this 52 here, because when you only have an I to get rid of I, to get rid of the i's in the bottom, all you have to do on those is multiply by I over I. And the reason is the top becomes 8i plus 16i squared, because you're going to distribute that I. And on the bottom, you get 2i squared. And see, an I squared, again, we get a substitute in place of this I squared, negative 1. So, I also have an I squared on the top, because I times that I is I squared. So again, in place of the I squared on the top, I get to put in here negative 1. So now when I take negative 1 times 16, I should now put that in front because that's the real part. And then I got a positive 8i. And that's all over negative 1 times 2 is negative 2. So now I split these up. That's negative 16 over negative 2 plus 8i over negative 2. And a negative divided by a negative is a positive, and 16 divided by 2 is 8. 8 divided by negative 2 is negative 4. And this would be my standard form of that problem there. Now this problem is the hardest one, so I am going to do it. You must first FOIL this bottom part. Now, I FOILed a problem like this just a second ago when I had a square one back here, so I'm going to go back and look at that. That was this one. I wrote it down twice, and I got this answer, but I'm going to do the shortcut for binomial squares. So the top part stays 5i. On the bottom, when you do a shortcut for binomial squares, you square 2, which gives you 4. You take 2 times 3i, which is 6i, times 2, which is 8i. And then you square 3i, which is 9i squared. So once again, in place of I squared, you want to make this negative 1. And negative 1 times 9 is negative 9. So what this gives me now is I have 5i, and this negative 9 plus 4 is negative 5 plus 8i. And now I have to multiply by the conjugate. So this is a lot of work because you are not allowed, you're not allowed to have an I in the bottom. So I'm going to take this times negative 5 minus 8i. And on the top, you got to put the same thing. So we are going to distribute 5i into these. So 5i times negative 5 is negative 25i squared. Nope, just I. Sorry. And then 5i times negative 8 is negative 40i squared. Now you should know what we're going to have to do with that I squared down here. On the other page, we FOILed the conjugates, so we got to square negative 5, which is 25. It's a difference of squares, and square 8i, which is 64i squared. So again, we have an I squared, so this is actually a value of negative 1, and this I squared is a value of negative 1. So this is negative 64 times negative 1. That's plus 64. So 64 and 25, that comes out to be 89 on the denominator. And then up here, negative 1 times negative 40 is a positive 40, and the i's are gone, so that's the real part. This is the imaginary part. And then the last thing you have to do is split those up over the common denominator of 89, because you're supposed to have a real part and an imaginary part. So there's most of those problems done for you. Then we get down here to this part. This says perform the operation and write the result in standard form. So now we are taking these problems and we are adding, but the problem is we don't have like denominators. I'm only going to do one of these. So if you look, this denominator and this denominator are different. So each part is what's missing from the other one. So you're going to multiply this part over here, because you need a 2 plus I and a 2 minus I in both denominators. So you're going to multiply this left side by the 2 minus I over the 2 minus I. And you're going to multiply this right side by this denominator on the bottom, which is 2 plus I over 2 plus I. Now, I hope you can see on the bottom we have conjugates. So on the bottom, you're going to square the 2. You're going to put a minus sign. You're going to square the I. That's I squared. On the top, you're going to distribute the 2i, so that's going to be 4i. And then 2i times I is going to be negative I is going to be minus 2i. And then we got this plus sign. And then we're going to do the same thing here. We're going to the bottom again is going to be the same. So down here we still have 4 minus I squared. Up here you get 10 plus 5i. And I made a mistake here. 2i times I is not just 2i, it's 2i squared. So now, in place of this I squared, we're going to make that negative 1. We're going to make that negative 1. We're going to make this one negative 1. So I hope you see that on the top part, we're going to have 4i plus 5i. That's going to be the imaginary part. That's 9i. And then that's negative 1 times negative 2 is 2 plus 10. That gives me 12 for the real part up there. And then the negative 1 is plus 1. So 4 plus 1 is 5. And then you split those up over the common denominator. So that's kind of a long way to go to get there. We got 2 more pages and then we'll be done. So up here, you're going to simplify these. And again, the first thing you want to do is you want to take the I out of the negative and bring the I out, just like on the first day. Take the 10 and make the negative out there. And then you are allowed, and you do not want to multiply these together to get 50. You want to put all the radical parts inside, and then the two I parts go outside. And then you break down your 10, which is 5 times 2. And then I times I is I squared. So over here, you got a pair of 5s in common. So you get to bring a 5 out, and you keep the 2 inside the radical. And then in place of that I squared, this is -1. So when you take -1 times this part, or that 5 is what comes out, this would end up giving you a -5 radical 2. And that would be your answer right there. We'll do this one. So when I'm doing this kind, first thing I would do is take the I out because of that. So we'll get 2 minus radical 6 I, and then it's squared. So you can write this down twice and FOIL it, or you can do the shortcut I did a second ago. Take the first term and square it. Take the first term times the second term times 2. So 2 times -1 radical 6 is -2 radical 6 times 2 is -4 radical 6, and the I is still there. And then you got to square this term. So negative radical 6 times negative radical 6 is positive radical 36. Or you could just leave them 6 times 6 because you're going to have to take a 6 out of there. And then I times I is I squared. So that I squared keeps showing up, and it's going to. That is -1. And I get to bring a 6 out for that. So -1 times 6 gives me -6 here. And this stuff will stay the same. And I hope you can see that this is a real and that's a real. So we got to take 4 minus 6, which is -2 minus 4 radical 6 I. This would be your answer right here. This is supposed to be a 6, just like that 6. I think we got 2 more sections and we're done. So this part says, use the quadratic equation, complex solutions to quadratic equations. Use the quadratic formula to solve the quadratic equation. I'm only doing one of these, and I'm going to do number 70. So number 70 says 9x squared minus 6x plus 37 equals 0. So you're supposed to know A is 9, B is -6, C, man, come on, pen, -6, and C is 37. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So I got to stick these numbers up here where they go. So I'm going to get x equals a -6 plus or minus the square root of -6 squared minus 4 times a times c, all divided by 2 times a. So now I have to simplify this big mess. So negative gives you a +6. -6 squared gives you 36. I'm going to do this on my calculator because 37 is a big number. So I'm going to take 36 times 37. And that's a negative times a -4 times 9 is -36 times -30, or times +37 is -1,332. And then 2 times 9 is 18. Okay, so now I got to take 36 minus 1,332. And when I do that, that's going to give me 1296. So I'm going to have 6 plus or minus the square root of -1296 all over 18. Well, 1296, I believe, is a perfect square. So I'm going to check on my calculator by doing the square root of 1296, which is 36. But do you see that negative sign there? So that gives me 6 plus or minus the square root of 1296, and I, down here I still have 18. And the square root of 1296 is 36. So this is 6 plus or minus 36i all over 18. And there's a common factor on the top. So the common factor is 6. When you divide out by 6, you get 1 plus or minus 6i. And down here on the bottom, 18 breaks down to 6 times 3. So those 6's reduce. So we got two answers here. We got 1/3 plus or minus 6/3 I. And you can make this 6/3 into 2. So you could have 1/3 plus or minus 2i. Now that's two different answers. It's 1/3 plus 2i, and it is 1/3 minus 2i. So those are pretty hard problems, and you got several to practice on. Over here on this one, please multiply by a number to get rid of fractions on both sides, and the same on this one. Multiply by fractions to get rid the numbers to get rid of fractions. The last part. Now, I've told you this a little while ago, and I'm going to repeat it again. I squared was -1. I cubed is -I. Man, oh man. This is going way longer than I'd hoped. I to the 4th is equal to 1. I to the 5th repeats all over again. I to the 6th is the next one. -1. I to the 7th. I to the 7th is the same as I to the 3rd, and I to the 8th is the same as I to the 4th, which is 1, and it keeps doing this forever. So if you have really big numbers with i's in them, I'm going to show you how to do this. I'm going to do it right here. So this one, again, I squared is -1, and we got -2, and I cubed is -I. So this is going to be -4 plus 2i, because negative times negative is a positive. I'm going to do this one right here. So this is going to be radical 2 with an I outside to the 6th power. So that means we're going to get radical 2 to the 6th power, I to the 6th power. So radical 2 twice brings out 1 2. So how many times does 2 go into this? Would be 3. So in other words, this is a 2 coming out 3 times. If you want to think about it, that means you have 6 2's inside a radical. That's what that 6 means. You got 6 of these. So that's 1, 2, 3 2's coming out. And then I to the 6th is the -1. So I to the 6th, I'm going to stick in -1 for that. So this is going to be 8 times -1. So this whole thing would be -8. Let's say I had a problem that said I to the 137th power. Here's how you figure that out. You take 137 and divide it by 4. And the reason you divide it by 4 is these things repeat every 4. Every 4 is the same. So I do this like always, and I get 12. I think I said 7. All right. Subtract, bring down the 7. You put 4. You do this deal right here, and you get a remainder of 1. When your remainder is 1, that is the same as being I to the 1st power. If this remainder was 2, it would be I squared -1. If that remainder is 3, it would be I cubed -I. If that was remainder 4, that would be 1. So this whole thing right here simplifies to I to the 1st, which is I. So that's what you would write for that answer. All right, I hope you guys had a great break. Sorry that took longer than I wanted it to, but sometimes that's the way life is.